Yeah, hi and welcome everyone to this coding along video for the Build a Large Language Model from Scratch book. My name is Sebastian Raschka and I'm the author of this book, and I'm planning to record a couple of videos for this book as a supplementary resource. So as you might know, there are 7 chapters in this book, and the videos will be from each of these chapters where I will hopefully provide a more, I would say, casual but also interesting take on some of the code examples. However, of course, the videos won't be as comprehensive as the book itself, so they work best in combination with the book. That being said, so I'm planning to record videos for each chapter. However, chapter 1, if we go to chapter 1 here, does not have any code examples. So I thought for this first video, I would show you how you can set up your Python environment so that you can then run the code for chapters 2 to 7. And of course, there are many different ways you can set up a Python environment. And here in this video, I'm planning to show you my personal preference. So how I would set up Python on a new computer. And yeah, even I sometimes think about how I would ideally set up Python. So recommendations change, and I try, to try to keep it simple, but also use the latest, I would say, recommendations and tools to provide an ideal experience. So I do have a supplementary resource here on GitHub. So GitHub is a place where I share some of the code for this book. And if you go to my account, RASBT, and then LLMs dash from scratch, yeah, you can get to this GitHub repository. And then there is this convenient setup folder that I set up here where you can find some recommendations. Like I mentioned before, I will be showing you how you can set up your own compute environment for this book on your own computer. Personally, I will be using a MacBook a MacBook Air, which is almost 5 years old now. And the code hopefully will run perfectly there because I made sure when I wrote the book that it runs on different hardware. So the book will automatically run on GPUs if you have a GPU, but it will also run just fine on older hardware. Because yeah, the goal for this book was to make it accessible to different operating systems, different compute environments, older hardware, and so forth. However, if for some reason the setup instruction here doesn't work for you, you may also want to consider, instead of running things locally, to, for example, consider cloud resources. So I can highly recommend, for example, Lightning Studio, which is one of the most convenient ways to run code in the browser or executing code via your browser where it runs on a different machine in the cloud. And there's, of course, also Google Colab, which is also a very widely used platform to run Jupyter notebooks. And for this book, all the chapters are available as Jupyter notebooks, which you can upload in Google Colab and execute there in case you have any problems setting up your own compute environment on your own computer. But yeah, to make this video interesting, let me actually show you how I would set up Python on my own computer. So for this, actually, this is a fresh also environment and setup on this computer just to mimic how, I would set up Python on a new computer. In this case, it's macOS. And I do have a subfolder here that is called Optional Python Setup Preferences. So the emphasis is on optional, that this is something I recommend, but you don't have to follow it. I mean, you can install Python your own way. However, this is how I would personally do it. And even there are multiple ways you can do it. So I used to be a Conda user for a long time. So Conda is a package manager for Python and a bit more than that. And I used it for a long time to manage my Python libraries. And in combination with Conda, I also used pip, which is like the native official way in Python to install packages. However, recently there's a new package called UV. And this one is essentially providing the same or similar syntax as pip, but also has some advantages and is very fast. So I actually recently also moved to just using UV because it's just much faster and it's a really nicely designed package manager. And the Python community is very excited about this. A lot of people in the Python community are using this. So I also thought I will show you how you can set up your environment using UV. And it's actually relatively simple. It's not more complicated necessarily than using any of the other two. That being said, there are also multiple ways you can use UV. So there is the UV pip syntax, which is very similar to the original Python pip package manager, but there's also the native UV syntax. For this tutorial, I will be using the UV pip interface because it's a bit more familiar to pip users. But if you are, more advanced or you're ready to explore the native syntax, also feel free to check out this tutorial here. So the first step here in our journey would be, of course, installing Python itself. So we can actually check if we have Python installed by, for example, typing Python -- version in our terminal. So this is in macOS, but I think it's similar in Linux and Windows. So here it says Python not found, which means I don't have Python, the command set up like this, that it would work this way. Another thing I usually also try is typing Python 3. And here you can see, in this case, I already have Python installed, or my operating system has Python installed. And actually right now, while I'm recording this, there is Python 3.13 available. Now this is 3.9, which means it's 4 version numbers behind the most recent Python release. And that tells me this must be some old version of Python that came with my operating system. So usually when you set up a new computer, it already has Python on it, but it's used by the operating system. And I highly recommend not modifying this Python version and also not just working with it, because you might break something and then it could cause trouble for your operating system. So I highly recommend not touching this Python here at all. And so what I recommend is just installing a separate version of Python. And you can do that in multiple ways. The official way would be, for example, going to python.org and installing it from there. So they have a menu here and you can download it for different operating systems. So I can, for example, go to macOS and then look for the latest release. And here it says Python 3.13. And another thing I wanted to highlight is I would recommend installing a slightly older version of Python. That's because packages like PyTorch, which we will be using in this book, they are not always supporting the latest version of Python. It usually takes a few months till PyTorch supports, let's say, the latest release of Python. So I would recommend, to be on the safe side, to adopt a version that is 1 or 2 version numbers behind. For example, Python 3.12 or 3.11. And you actually won't miss out on anything because, you don't use these most recent features in Python anyway when you do scientific computing. So in this case, it's safe to install a slightly older version. And so for this book, I tested it on all versions like 3.10, 11, 12, and also 13. It works just fine. But to be on the safe side, as a general rule of thumb, I recommend installing a slightly lower or smaller version, for example, 3.11 or something like that. That being said, there are many ways to install Python. I, on this computer, use Homebrew, which is another package manager. So if I go here and type Homebrew, you don't have to use it, by the way. It's just something I happen to use on this computer, and it's called the missing package manager for macOS. And so it allows you to install certain tools that don't already come with macOS. But you can also, for example, use it to install Python. That's just personal preference, but you can also just download it from the website. There are multiple ways you can install Python, but that is just how I would do it personally. So you can type brew install Python, let's say 3.11. And that would then install Python. So that would be the first step. And then the second step would be setting up UV. So UV is this package manager, and you can install it via pip install UV. So if you have Python already installed, pip would be the Python package manager, and we use that to install another package manager. And the reason we do that is because UV is actually faster than pip, and it's just more convenient to use it, in my opinion. Now, looking at the output here, it says Python is installed now. It's installed in this folder. And there are some advanced ways you can actually link it so that when you type Python, it will automatically use this Python. But for simplicity, let's just use the commands from here. And it says, for example, you can install Python packages with this command. So it's slightly different from what's shown here. But yeah, I will just use this command. You can link it on your computer that it is just pip, but for brevity, I don't want to overcomplicate things here. We are now installing the UV package manager. And so this was very quick. It's installed now. And the next step after that is creating a virtual environment. This is not strictly necessary, but I highly recommend this. This means a virtual environment means that it is a separate folder on your computer where all the packages are installed. And in this case, it will also bring its own version of Python. This means if you are messing anything up by accident, you can just delete this virtual environment and start over without messing up your whole computer. So this is actually something I highly recommend. So before I execute this though, let me do one more thing. So let me actually download this GitHub code here. So I go to my GitHub repository, and then you can click on download the zip, and it will download this here, in this case, to the downloads folder. Let me just open the downloads folder, and then let me drag this to the desktop because then it's a bit easier to see. So I have now this folder, and I can go in here, and you can see the contents of the folder here are the same contents that are shown here on GitHub. So I just copied or downloaded this GitHub repository. Now let me actually navigate to this folder. It might be a bit different on Windows, but this is how you do it on macOS and Linux. And then I can also show the contents of this folder here. Now, let me create this virtual environment. So there was this command I just showed you. Where was it? Here, this command. So this uvvenv, this will create a virtual environment, and let's just use Python, let's say 3.11. And this will create a folder called venv. We can double check. Now it's here, and it has its own version of Python. So in case we mess anything up, it will actually not be a problem. We can just delete this folder, and then we should be able to set it up again. So what I mean is, if we mess anything up later on, I can just delete it and then recreate it like this. Now, there's one more thing I want to say is also, you may not be able to see this folder because it starts with a dot, and files or folders starting with a dot are by default invisible in the Finder. So there's a Finder option that you have to enable to make invisible files and folders visible. But here, let's say it is visible. Assume you have created this venv folder. The next step would be activating this. So creating the virtual environment is only something you have to do once, unless you delete it. But then every time you work with it, you activate it. So now this is active, and when I type Python, so I can type Python, and there's this command which shows you which Python version you are using. I think on Windows you have to type where, but let's stick with this because this is macOS. And you can see it's now using, when I'm executing Python, it's using this Python from my virtual environment. So let me do this. So this should be Python 3.11 from this path here. Again, I can delete this. So let me just get rid of this. If I type Python version, it won't be available because I just deleted it. So in this case, we have a virtual environment that is just very specific to this folder. And if we mess anything up, we can just start over again. And installing packages works like this. You can do uv pip install, and then there's a package called packages. Let's just install that. So it will then install this package. Or if we want to install PyTorch, we can type uv pip install torch. So for some reason, the PyTorch team named the Python package torch instead of PyTorch, so something to remember. PyTorch is the main deep learning library we are using in this book. So now I installed Torch or PyTorch. And yeah, so we could do that for all the packages that are used in this book. And in the chapter itself, I'm usually telling you which package needs to be installed. But if you want to make this super convenient and not just, executing this one by one, you can actually go here and there's a file called requirements.txt. It's also the same here on GitHub. If I go to the main view, there's a requirements.txt, and it lists the latest or the packages that are required for running this book. So if you do pip or uv pip install -r requirements, you can install all the packages all at once like this. And yeah, so in this way you are done. You don't have to do anything in addition. This should install all the packages that you need for this book. Now, if you're running this on Windows, you might encounter an issue with TensorFlow IO GCS file system. And this is a bit annoying. So the reason why we need this is that OpenAI released the GPT weights for the GPT-2 model, an LLM that we are using in chapter 5, as TensorFlow code back then, and the weights are in TensorFlow. We are not working with TensorFlow in this book. We are using PyTorch, which is the most widely used deep learning library at the moment. However, just to open these open weight files, we have to briefly use TensorFlow, and this is why it's a requirement. However, it might create some problems on Windows. So if you don't want to worry about this, you could either go into this requirements file here, delete TensorFlow, save it, and then just run this command again, and then worry about installing TensorFlow at a later time. You can also, without having to delete this, I think what works, because it will build it from source, you can leave it in here and just run pip install without UV, and this should also work. So like this. However, in case this also doesn't work, there's another backup option, and this would be using Google Colab. So if you go to Google Colab, this is a way you can run notebooks in the cloud. It's free. And what you could do here, let me do a new notebook. So you can install, for example, again, UV. So you can type pip install UV. Usually, it's not always required, but it's usually a good idea to add this exclamation mark if you are running this in a notebook. And then, so what you can do is you can go here to this main folder, click on requirements.txt, click on raw, and copy this link here. Go here and type uv pip install -r, and it will install all the required packages here. One more thing to say is we have not created this virtual environment. So this is why we are seeing this error here. And in Google Colab, it would be overkill to create this virtual environment. I mean, we could do it with this UV venv, for example, but this would be overkill because Google Colab is already a virtual environment. So every time you open the notebook in a new session, it will be a fresh environment. So in this case, since it is already a virtual environment, we can just type system, and it will treat it like such, so that it is not creating a separate virtual environment. But it's really up to you. This is like just a bit simpler. It's one less step to worry about. Oops, it's one mistake. Oh, I made a typo. I forgot an S. So yeah, so this is installing all the packages in Google Colab now. And then we could, for example, execute the code for this book in Google Colab. And by the way, this command also works locally. So if you don't want to download the GitHub repository, you could also just copy this in here with this URL and install all the packages right here. Here it already has the packages, so it didn't do much. But if you run this for the first time, this will install all the packages. And then once we have this installed, we can do UV run and open a new Jupyter Lab environment. So Jupyter Lab is a way to open Jupyter notebooks. By default, this will open up in your primary browser. And then, yeah, we can open the code for the different chapters, for example, or we could make a new notebook. So that's what I recommend when you're following along with this book, either to make a new notebook and run the code here. Or another thing is you can open an existing notebook, but it would be a little bit of a spoiler if you see already the output. So I highly recommend going here and selecting clear outputs of all cells, which will delete the output so you're not seeing the output. But I think to get the most out of the book, I highly recommend just doing a fresh notebook. And actually, it's a lot of work, but actually typing the code, because that's actually a really good learning experience, because then you also see, or you pay more attention to the code than just copy pasting it or just starting with an existing notebook. But yeah, I don't want to go too much ahead here and start already talking about the code in chapter 2. We will do this in the next video. I hope this video was useful to you and showed you one way you can set up your computing environment. And yeah, if you have questions, please feel free to comment. I'm happy to answer questions you might have. And also know if nothing works, there's always Google Colab, or there are other environments I can also share where there will always be a possibility that you can run the code. So don't worry about it. But if you have any questions, please let me know. And I hope this video was useful. And yeah, I hope I will see you in the next video.